Are we on? Are we good? Okay. Good morning, and welcome to Atomic News. My name is Charles Zimmerman, and this is the latest news on crime in Ion City. Today, we have learned of a series of electron stealing by fluorine in Ion City. Fluorine has stolen an electron from lithium. After lithium's electron was stolen, he became a positive ion, or cation, and an advocator of justice for other elements who had their electrons stolen. A prize is being offered for the capture of fluorine, who made himself a negative ion, or anion, after he stole the electron. Other thieves who have stolen electrons are chlorine, oxygen, and sulfur. Oxygen stole 2 electrons from magnesium to complete his octet. Oxygen only has 6 valence electrons, and magnesium had 2. Chlorine stole an electron from silver, which is a transition element. Sulfur stole an electron from the 2 different potassiums, since potassium only has 1 electron, and sulfur needed 2. By stealing these electrons, they became ionic bonds. Fluorine, lithium. Fluorine only had 7. Lithium had 1. Fluorine needed 1, so he stole 1. Sulfur had 6. Potassium had 1, so he stole an electron from 2 potassium. Cl, or chlorine, had 7. Silver had 1, so he stole 1 to complete his octet. This is not very regular because Ag is a transition element. Oxygen, here, as shown, has 6 valence electrons and needed 2, so he stole 2 from magnesium. By stealing these electrons, they form ionic bonds.
You gotta talk about What's that? We're on? Hi, welcome to Atomic News. I'm Don Burgundy, bringing you today's music news. In Ion City, a record-setting crowd has formed to see the gathering of a band, Metallica Bonding. This is the band's last show before retirement. Metalheads across the country have come to witness metal history. A sea of electrons has truly shown up today. The electron sea model proposes that all metal elements in a metallic solid contribute to the valence electrons in a sea of electrons. As you can see, the positive elements here, and the element gives away their electrons to form a sea of electrons. At the lawn section of the concert, a mosh pit formed of gold elements in the concert's excitement. The gold elements easily gave away their electrons, creating a strong bond between the metalheads. The music flowed through the mosh pit with ease. Because the gold elements had so many electrons, they each contributed their electrons, creating a flow of energy and music throughout the mosh pit. However, in the seat section of the concert, a weak metallic bond of sodium formed due to their difficulty sharing electrons. Since sodium has less valence electrons, they have less to give, creating a harder way for energy to flow throughout the concert. Metallica Bonding came down after the concert to meet the fans. The metalheads swarmed the band, creating an interstitial alloy. An interstitial alloy is an element like brass. Brass forms when small holes in the metallic crystals are formed with smaller atoms. As you can see here, Metallica Bonding came down into the fan section, and the fans swarmed Metallica Bonding, creating an interstitial alloy. The gathering of the band members became so hectic that security guards were called in to replace the band members. This formed a substitutional alloy. An example of substitutional alloy is an alloy such as bronze. Because security guards replaced Metallica Bonding, they are substituting them out for the fans, creating a substitutional alloy. That's today's music and news, and here's Logan.
Thank you, Don Burgundy. In other news, we have a story from the east side of Ion City. Oxygen, an atom with 6 electrons, is sharing with hydrogen, an atom with 1 valence electron. In this touching case, both atoms share valence electrons to obtain a full octet, a perfect example of the good in atomic nature. Though all things are not equal, oxygen spends more time with the electrons gaining a partial negative charge, while hydrogen spends less time gaining a positive charge. This is called polarity, and thus the dihydrogen monoxide relationship is at a bent angle of 145 degrees. Seen here, and this demonstrates the flow of electrons to oxygen. In other news today, the Salvation Atomic has recently given away its own electrons in a large act of kindness. This is being called a coordinate covalent bond. Expecting nothing in return, the Salvation Atomic has donated a complete pair to boron trihydride, giving both a complete octet, illustrated here. We're also seeing new developments in how atoms help each other. Many share single bonds with one another. In the world, this is represented by a sigma bond, represented by the Greek letter sigma. A sigma bond is a direct overlap between valence electrons. In this bond type, both parties donate a single electron to help one another gain a full octet. While this is usually the closest that strangers will get, family and friends sometimes will donate more to help one another. Any bond greater than a sigma bond is represented by the Greek letter pi. Because families and friends already share sigma bonds, they must find other ways to bond further. They do so by creating nodes and fill those nodes with electrons. Illustrated here and here. How much time?
Yeah.
Okay. What's that? We're on? Hi, welcome to Atomic News. I'm Don Burgundy, bringing you today's music news. In Ionic City, Illinois. Dude, it's so hard.
It's not hard.
Yes, it is.
It's
Ionic
Ion
City. Is it
Ion City.
Ion City.
Ion City.
Ion
God.
City. Yeah.
You're worse than me.
I keep on seeing Ion City. Gotcha. All right, we're gonna do this time.
Right.
Are you sure?
Yes. You ready?